So we are going to work on this textbook problem using the Markov process. So why don't you just pause the video and read the question, and then we will work on it. Okay. So what we have here is, or rather are, two companies, U and O, and we have to find a 2 by 2 matrix, and we are calling it a T, which shows the transition or switching and staying with each company year to year. All right. So what you have is that we are given that 98% of the subscribers of U stay with U, while 2% move to O. Okay. And on the other hand, 95% of the subscribers of O, they stay with O, okay, all right, while 5% move to U. So, each row has to add to how much? 1 in the way we are writing it. So here is our transition matrix, which is also regular because we need, for this part, the steady state matrix, we need the transition to be regular, which it is, because some power of this matrix has to have all the positive entries, and here the power 1 already has all the positive entries. Okay, now we have to find out the market share of U, that is what percentage of people subscribe to U after 1 year. So right now the position is this. If you look at it, U has how many? 28% of the market share, right? So others will have how much? 72%, right? So the way we saw through tree diagrams and everything in the explanations, that is, product of this 1 by 2 matrix with this 2 by 2 matrix will give us the market share, or the number, or the percentage of subscribers of U and O after 1 year. So let's just go ahead, and since we did matrix multiplication a lot by hand, now we are going to go ahead and use technology. All right. So here we have our transition matrix T. All right. And this is the share of U, and this is the share of O, the others. Okay. And if we multiply these two together, we get this matrix, and that simply means that, well, this is the transition, right? And this is the share of U this year. So a year later, the percentage of subscribers that use U is 31% instead of 28, and O is this much. Now, what we have to do next is that we have to do the same thing 2 years later. And you saw that what all that we have to do is do the same thing, or take this matrix here. Okay, and so let's just take them, and let me bring it down here. Okay, and 2 years from now, we just have to multiply by the second power. Okay, and again, the same way, this is the share of U right here, and this is the transition matrix square for the 2 stages from now. So when we do that, what we get is this. That is, let's just multiply them together. That now the share of U, or the percentage of subscribers that use U, goes up to about 34%, and O is 66%. And then next question was that we have to do the same thing 3 years from now, right? 3 years later. So what you have here is that instead of power 2, what we will do is that we'll take the transition matrix to the third power and multiply that with this initial state, and again the first entry is being U for this year. So then what happens, like the subsequent year, or in this case 3 years since the initial stage, the market share of U, just goes up to 36%. Now we can do the same thing in our TI-84 graphing calculator. Let me just quickly show you how. So here is our calculator. First, let me remove the writing so that we can see better. So what we will do is that we shall create two matrices. So we'll go to second matrix, and then we are going to edit, because what we are going to do is that we are going to, let me move it a little further up right here. Okay, so what we will do first is that we are going to write our matrix, the first matrix here, which is 0.2, okay, this is 1 by 2, all right, and this is 0.28, okay, so that's what that takes up, and this one is 0.72. The two rows have to add up to 1. So this is our matrix A. We can change the name if we want, and then what we will do is that we shall again go ahead and edit the matrix B. I mean, we can call it T if we want, but for our purpose, just for simplicity, that we will have the matrix B serving as our matrix T. Okay, so just a moment. Yeah, this is a 2 by 2 matrix, right? And what we got here is that we got 0.98. Okay, and then in the second place we have 0.02, and then we've got 0.05, and then we got 0.95. Okay, so this is our transition matrix. Okay, so again, A is our initial state matrix and B is transition matrix, and what we can do now is that we can just recall them here. We got A, and then say bring B back. Okay, so AB, and AB is going to be exactly what we have here, 0.3104 and 0.6896. Now for the second one, like 2 years from now, all we got to do is just press second enter and raise power. Which power? Power 2 on B. So what do you get? 0.338672 as you had before. Then for the next one, you can just keep on doing this. Just change, 1 second, sorry. Just change this 2 to 3, and you get the subsequent stage as you had here. Okay. And so what we have to do now is that we have to find the steady state of this matrix T. And what do we mean by the steady state? We mean this, that is a state in which, say, the present value of P is, of the share of U is P and that of O is Q, then it doesn't change. Or in other words, say this, to find a row matrix like this, which doesn't change at all after multiplication with this matrix, that is PQ times the transition, remains the same. And what we mean by that is, let me just write this as P and this as Q. And notice this, if we have this quantity squared, then what is happening is this. What do we mean by square? That the same matrix has been multiplied with itself twice. So what happens now is that this portion here you saw has to be PQ, right? And so this is PQ. So when we multiply PQ with this matrix T, what we will get? We will get PQ again. And that will just keep on repeating no matter how many powers we raise on T. All right. So let's just go ahead and find this steady state matrix PQ, or this one. And since now let's just go ahead and get the handwriting out of here. Okay. So here we go. And so what we have is that we want to get matrix PQ such that this happens. So what we will do is that we will multiply these two. Now let's do the multiplication. So we are going to have a 2 by 2 matrix, okay? And on the left hand side, that is, we are multiplying these two. So what we will get is 0.98p, okay, plus q multiplies with this, so 0.05q. And then what we get here is 0.05p and then plus 0.95q. Now notice this, I was using technology and I forgot myself that product of 1 by 2 and 2 by 2 matrices has to be a 1 by 2 matrix, all right? So anyways, so this is what we got, okay? And then if we compare the two sides, what we will have is this, that is, we got this equal to P, and then we got this equal to Q, okay? Now what happens is that now we will have negative P plus this quantity. If we move P to the other side, or subtract P from both the sides, and that will give us, what will that give us? That will simply give us this here. Let me just rewrite it. So what happens here is this, that if you look at this portion here, which is negative P plus 0.98p, and I'm going to just too much basic here, but sometimes I've seen people getting confused with that. So notice that here I'm, losing a pound, and here I'm gaining 0.98 pounds. So I will be losing 0.02 pounds just because this may be treated as this quantity. So let's factor P on the right hand side, and negative 1 plus 0.98 would be how much? Negative 0.02. So what that gives us is negative 0.02p plus q equals 0, right? Not q, sorry. 0.05q equals 0, okay? And likewise, what would this give us? This will give us 0.05p plus, or rather minus 0.05, just a second. Oh, it's the same thing happening, that I started using machine to do computations and I forgot it myself. See, I made a mistake here because this had to multiply with this. So this should have been 0.02p, and same here. So it's like many mistakes repeating. Okay, so let me erase the handwriting and just rewrite that part for you. Okay, so what we should have had is, and again I'm sorry, my apology is not withdrawn, it's erased though. Okay, it's 0.02p, 0.02p, and when we move q to this side, that will be negative 0.05, q equals 0. So, but the trouble is this, that if we look at these equations together, okay, they simply give us what? 0 equals 0, all right? That means the two are equivalent to only one equation, but we still have one part with us. That is, what we know is that in this case, our entries P and Q, so moment, they have to do what? They have to add up to 1. So what we got is that we can choose any of these two equations that we would like, this one or top one. Both of them are going to give us the same result. Okay, so P plus Q equals 1, and this equation, and we are just so let's just go ahead and do what, and just solve them. So we got P plus Q equals 1 and 0.002 minus this equals 0. And even though I saw that when I got used to machine, I started making mistakes, but I think I have been just talking about this for way too long. All right. So I'm using machine, but the thing is this, that I'll keep in mind to keep the procedure with us. So what do? You can just go ahead and compute the row reduced echelon form for this. And you can even use your calculator to do that in the following manner. So what I did here was that, I already entered, this is a 2 rows and 3 columns matrix. Okay, or rather, this is a 2 rows and 3 columns matrix. So I already entered those columns in there. See, 1, 1, 1 and negative 0.02, negative 0.05, positive 0.050. And now we shall row reduce, or rather find row reduced echelon form of this. So we'll go to matrix option here, and then we are going to look at math. So let's just scroll down, and this procedure here. So we have this, and what we got here is that we just want the matrix C, and I'm going to just do it in a point click way. So you can see that you have the same answer for steady states for P and Q in here. And of course, rounding off is sooner. And we have this, that, see this here, 0.02 and negative 0.05, they're simply fractions, like 1 over 50 and negative 1 over 20. By fractions, I meant rational numbers, sorry. So if you want, you can have this give you the answer as rational numbers. Just go to math and say, I want fractions. And this also means rational numbers here. And sometimes people use them, for different meaning. So if we do that, you can see our P is 5 over 7 and Q is 2 over 7. And these are their decimal approximations. So what our answer is this, and this is still sitting here. Okay. So, no, sorry about that. We wanted 1 row and 2 columns, right? So rows 1, columns 2. All right. So, and what we have is 5 over 7 and 2 over 7 as a steady state. And in this case, if we talk about it, it looks like that eventually, after many, many years, you will have 5/7 of the subscribers. But let's not stretch it in application that too much, because what you will see is that it depends on the rate at which the convergence is occurring, that how long it will take to converge to that value, and whether the steady state will hold all along that time or not. Okay, so I'm just going on speaking, and you can just stop listening to me anytime you want, because the problem is solved. So what we wanted is, we want to see if this will turn out to be again the same matrix. So let's just first change it to fractions. Okay. So we changed it to fractions, and if you multiply them together, you will see that it stays as what? 5 over 7, 2 over 7. Now let's see how long does it take to attain the steady state. If we have this, where is my initial calculations have totally disappeared somewhere. Okay, but that's all right. So remember this, that at this stage, like at the beginning, I'm just talking now just to show you that if the convergence or the rate at which it approaches the steady state is very slow, then it may be impractical to assume that it will get to that state, because so this is the present situation. Let's look at it, say 10 years later. Okay. So what happens? It's not even close to the steady state here, right? Okay. And say we look at it, so one second. Let me just do this here. Decrease this size. I hope you can still see it. So you can see that even after, what do you say 10 years, we have not even gotten even close to this steady state. Here is 50%, this 71%. Let's see what happens after, say, 20 years. Okay, so it's still, quite far. All right, so this is because of this slow convergence. So sometimes the convergence will be slow, sometimes it is fast, and we are not going to go into the mathematics of all that in this basic course. And even after 30 years, you can see that even though it's approaching that, but the thing is that it's far from obtaining this value point 7143, and it's not costing me anything to do it this way, so I'm just going on doing it. All right, so one moment. So let's see what we'll do after 100 years. Okay, all right. So there it at least went up to 0.714, but in 100 years it's very impractical to assume that the same transition pattern will continue, and there's so many things that can change in the in this particular scenario. But we will have examples, and you have examples in your exercises rather, in which the convergence would be faster. So just go ahead and work on the exercises and enjoy. Okay.